In this video I will be demonstrating how to solve the SO3 problems. That is, how to solve the second order equations that are non-homogeneous using the method of undetermined coefficients. Our particular problem is the second derivative of y plus 9y is equal to 2 sine of 3x plus 3x squared. The general method here is going to be to create a general format of a solution and then solve for those coefficients. But to get what that format is, we first need to figure out what it's not. And to do that, we need to look at the corresponding homogeneous equation. That's the second derivative of y plus 9y equals 0. We solve this using the familiar methods of looking at the characteristic equation, r squared plus 9 equals 0, which has roots plus or minus 3i. The imaginary roots correspond to the sine and cosine solutions, and so the complementary solution is c1 cosine of 3x plus c2 sine of 3x. That means if we tried to incorporate cosine and sine into our general answer we're going to make, all they're going to produce is zeros when we plug them into the equation, so they're not going to be helpful. Alright, to figure out what we actually need, we need to look at that right-hand side and its derivatives to see everything that could possibly show up. So the right-hand side was 2 sine of 3x plus 3x squared. Its derivatives are 6 cosine of 3x plus 6x, negative 18 sine of 3x plus 6, and negative 54 cosine of 3x. So inspecting this, we see that sine and cosine of 3x will show up, and x squared, x, and constant terms will also show up. Okay. The sine and the cosine of 3x overlap with what was in our complementary solution, which means we cannot use them. We have to modify them first, multiply them by x to make them no longer line up, and then we'll be good to go. So our particular solution looks like ax sine of 3x plus bx cosine of 3x plus cx squared plus dx plus e. Now, we need to find a, b, c, d, and e to finish out our answer, and the only way to find these is to plug this particular solution into our original equation. So to do that, we'll need the first derivative and the second derivative. The first derivative uses the product rule on ax sine of 3x and bx cosine of 3x, producing 3ax cosine of 3x plus a sine of 3x, and negative 3bx sine of 3x plus b cosine of 3x, and then just the power rule on the rest, producing 2cx and d. We basically apply the same thing to get the second derivative of this format, and after a little bit of work you get negative 9ax sine 3x plus 6a cosine of 3x minus 9bx cosine of 3x minus 6b sine 3x plus 2c, what you see there on the screen. Alright, so this is what we need to plug in. So we have the second derivative of y plus 9y equals 2 sine of 3x plus 3x squared. Expanding all this out, second derivative of y was what you see in blue, and y was just what you see in purple there. So all we need to do at this point is a bunch of arithmetic. We need to multiply the 9 out by y, which we do here, and then combine various like terms. You'll notice since ax sine 3x terms cancel with each other, and same with the bx cosine 3x terms, but we do have cosine of 3x and sine of 3x terms still hanging around, as well as x squared, dx, and constants. Alright, so we line all this up to basically compare the left-hand side to the right-hand side and solve for our coefficients this way. You see we have sine terms on both sides and x squared terms on both sides, but the right-hand side does not feature cosine, x, or constants. So formally, to write out how we get all these coefficients, we just write down all of the equations we get. So 6a is equal to 0 because there is no cosine term on the right-hand side. Negative 6b is equal to 2 because that's the coefficient in front of sine. 9c is equal to 3 because of the 3x squared, and everything else is equal to 0 because we don't have an x term or a constant term. We then have this arithmetic to do. We divide the a and the b equations by 6 and negative 6 respectively to get 0 and negative a third out. We divide the c and d equations by 9 to get a third and 0 out. And then we plug 1/3 in for c in the bottom equation involving c and e to get 2/3 plus 9e equals 0. and then eventually e equals negative 2 over 27. So this is what we're going to plug into that format of the particular solution that we found earlier. Recall that that was ax sine 3x plus bx cosine 3x plus cx squared plus dx plus e. So we will have no x sine 3x term, no dx term, but we will have a negative 1/3 x cosine 3x, a 1/3 x squared, and a negative 2/27 for a constant. So the particular solution we found is negative 1/3 x cosine 3x plus 1/3 x squared minus 2 over 27.